Welcome back, aliens. My name is Navin Reddy. It's time to talk about exceptions in Python. Now, we have talked about the good things, right? Now we know the basics. We have talked about OOPS concept. Now, when we talk about exceptions, they are something which you have to handle. Now, what if you don't handle them? First of all, what is exception? How it works, how to handle them. So we'll divide into multiple segments for this particular topic. But let's talk about why you have to handle certain things. See, when you build applications or as a user of the application, whenever you use any app, it can be on your phone or it can be on your desktop, you expect them to work, right? And you expect them to give you the response which you are expecting, right? So a lot of expectations there. But the point is, the app should work. The app should work smoothly, and then it should not crash. But then if you talk about the kind of application which you are using, so there are some applications which are not very critical. There are some applications which are very critical. Now, applications which are not critical, example, let's say calculator. Now, of course, if you want to calculate something, you can do in your mind, but we are lazy. So you open your calculator and you start typing something. And then what if something goes wrong and your app crashes? That's fine. I mean, of course, you'll be angry, but then you can simply reopen it, enter the same number, and you're done. But what if the app which you're using is critical? Now, see, when you talk about app, you picturize something, right? You have an image of an app in your mind that it should be visible, and then you are clicking something. But if you talk about the hardware which we use, they are using a software, right? Example, the plane, the car, the MRI machine, all these are actually running on softwares, which you can't see. Because that's how the things work, right? You see the hardware and then the software are running behind the scene. Even if you buy a new car now, all the modern cars, they have a lot of softwares in it. So they have a lot of semiconductors and softwares. And what if you are on the highway and something goes wrong with the software and it crashes? Okay, it should not happen, but then you can see the impact, right? So these are mission critical softwares for the flight, for the MRI machine and banking applications. So you have to make sure if something goes wrong, of course, things will go wrong, but it should not crash the software. It should not stop it working. So those things which comes are called exceptions and you have to handle them. Okay, so we'll divide it into multiple sections for this particular video. First, we'll talk about what are exceptions. And in fact, we'll start with different types of errors. We'll move towards exception and then we'll see how do you handle it. Now, let's talk about errors here. Now, if you talk about a code can have different type of errors, okay? In fact, to show you that, I will open any code, okay? Randomly, I will jump to, let's say, this code, okay, which is fact recursion. So we have done this before. Now, if you have reached till exception, I guess you know what is factorial is and recursion is. So let's say if you talk about this code, and in this code, there can be different types of errors. The first error could be a compile time error. I don't know why I was saying logical error, but yeah, compile time error. Now, what is a compile time error? Now, whenever you make mistakes with the syntax, okay, so when you play around with, you're not doing something correct as per your compiler or the interpreter, it will complain. Example, let's say, if you talk about this code, what if you make a mistake here? So instead of saying single F, you typed double F. As soon as you do that, your IDE, in fact, if you're not using IDE, if you're using a normal editor, your Python interpreter will give you error. But your IDE says, what you're doing? This is an error. There's nothing called def here. Okay, so as a developer, you know, okay, you have written something wrong and your compiler is shouting at you or your IDE is shouting at you. That's a compile time error. And one of the most easiest error to solve is the compile time error, is because as a developer, when you're typing it, you can see the errors. So sometimes if you write something in the if condition, you might not see the error by the IDE. Example, if I write break here, okay, it gives an error. Yeah, if you write pass here, there's no problem. If I say PAS, you are getting a warning, but you can see there's no error on the screen. And it's actually an error. There's nothing called pass, right? So I mean, PAS, not PASS. PASS does exist. So you got the point, right? So at least your IDE, your interpreter will help you. So when you run that, it will say, hey, what is pass? I don't know. The second kind of error which you normally get is a logical error. Now, what is logical error is when you have some logical mistakes which you have done. Example, let's say in this code, if you try to run this, first of all, I have to go to the folder, cd basics, clear. And now if I try to run this, which is fact_recursion.py, you can see we got 120, and that's what the factorial of 5 is. But if you make a mistake here, let's say if you instead of returning 1, you returned 2. Now in this case, you will get a different output, and that's 240, which is incorrect. And this is a mistake, right? This is a logical error. There's nothing wrong with the syntax. Everything works. Now, since you made a logical mistake, you will get a different output. Now, this is actually tricky, okay? So this is difficult to find this type of errors is because if you know for 5, it should be 120, and if you get 240, then you know that's a problem. But what if you have written something and you're getting an output and you're not sure if that's a correct output? Example, let's say if you're fetching something from the database, let's say you want a name of an employee with the ID 5, and if you get a name, let's say Naveen, and your expected was Harsh, and you don't even know you're expecting Harsh, you got Naveen, you're happy. I mean, that's what you get in college and dummy projects. You get some output, you feel happy. But that's a mistake, right? You got a different answer, or you got a wrong answer. Now to solve that, basically we have a team, right? So the developer, you test it first, then you have a testing team who will test it. And then if something goes right, or if everything goes right, then only you will make it into production. And in production as well, sometimes it breaks and sometimes it's not giving the correct output. You do A/B testing, you do testing with your client, and then they give you some feedback. So that's the entire process. That's the logical error. The third kind of error is the runtime errors, or you can say exceptions. Now, exceptions are actually tricky because this is not the problem by the developers, right? So they have done everything correct. It's a mistake from the user, okay, most of the time. Because let's say if you are dividing a number by 0, as a developer, you will not do that. But if you are doing an operation where you're dividing by 0 and this input is coming from the user can say divide by 0, and then it will give you an exception. Second, let's say your app is looking for a file, okay? So if it has to work, you need to have a file where it stores data, and that's in your C drive. When you are developing the application, the file was there, and you have never got an error where it says file not found. But now let's say you have given this application to your user, and user knows there should be a file in the C drive. Maybe it automatically create that file, and everything is working for a few days. One day, user got an error by saying, your C drive is full. And then user start deleting some folders or some files. And one of the file is the file which your app needs. And then user deleted that file. And now you're trying to open the app and the app crashes. Not because of developer's error. It's the user problem. They have deleted that file. And when you get an error like that, your app will crash. And you don't want it to happen. And that's why you should handle it. Now, how will you do that? So basically the concept is exceptions. So let's try to handle the exceptions. And to do that, what I'm going to do is I'm going to create a new folder, and let's say advanced, because now we are in the next step of Python. So let's say advanced, and in this, let me create a file called exception demo.py. And in this, let's write code. Now, first of all, I'm not going to disable my Copilot for this particular videos because now you know the syntax. Even if AI is helping me to write the code, why not? Okay, so let's write some code. What I'm expecting here is, let's say I got two values. One is A, and the value of A is 5. Then B, the value of B is 2. And I'm going to do a very simple operation where I'm going to store this operation of divide into a result, and then I'm going to print it. Nothing fancy, simple stuff, right? If I run this, so of course I have to come out of basics. Let's get into advanced mode and clear. Let's run the Python. So Python exception -demo.py, enter, and you can see we got the result as 2.5. Everything works, no problem. Happy life, happy code. Okay, so let's print one more thing here, which is, let's say end of program. I was supposed to type by, but then Copilot suggests write end of program. Now, why I'm writing this is because when you execute this, of course, your application has so much things to do. And let's say that code is here, not just end of program. Let's say we have a lot of code. If this executes, I'm expecting other things will also execute. Okay, so if something breaks here, this will not execute. So if I run this code once again, it works and it says end of program. Or it will say end of execution. Okay, now let's say I make it as 0. So if you make the B value 0, let's see what happens. Enter, you got an error. And this is not the first time we are getting error, but something to observe. First of all, it is giving you the reason on line number 5, because of this operation, you're getting the error. You also have this operation here. It says this is a problem. This slash is a problem here. Actually, the slash is not the problem. The problem is B. The value of B is 0. And you can see you are getting a message as well, which is division by 0. And observe this 0 division error. We'll talk about this later. But let's look at the message, which is division by 0. And one thing to observe, this message, which is end of execution, is nowhere. That's trouble, right? Because I want it to be there, because the app is crashing and I don't want my app to crash. So how do you handle this? Now, when you say you want to handle something, you can basically look into the statements and decide which of them are critical statements and which of them are normal statements. Now, what do you mean by normal statements and critical statements? So let's say if I'm going with my family and I have a kid as well. So let's say we are going to a mall, and in there we went to a restaurant and we are having our lunch. And at this point, let's say my kid got up from the table and just trying to run away somewhere, so to a different table which is empty. Will I be panic? Depending upon situation, it's a restaurant, it's a closed restaurant, and the next table is empty, so no one is there to get bothered. It's okay if my kid gets up from my table and goes to the other table, right? Where else he will go? We have a short space there or small space. And that's a normal situation for me. But now think about a situation where I'm going on a different city, and then on the highway, we got a small restaurant, or maybe called dhaba. I'm waiting there, and we are having lunch. And now the open restaurant, which we can call it, is next to the highway. And now my kids get up from the table. Now that's a panic situation, right? Because we have a highway there, the road, the vehicles are coming there. And that's a critical situation. So I will just get panic. I will jump and hold his hand, right? So that's a critical situation. So depending upon situation, you will try to handle it. In this particular code, these two statements looks normal to me. What will go wrong there? But this line is critical. So what I will do is I will try to handle it. And the way you can do that is by writing in a try block. Okay, so this is a try block, and this is the code which you want to write in a try block. Now, what try block will do is try block will say, okay, anything inside my block will be handled critically. So it will try to execute this. It will say, let me try to execute this statement. If it works, that's great. If it doesn't work, I will handle it. But then to handle it, you have to write, and you can see if you go here, it says try statement must have at least one except block. So you need to have the except block here. And except block says you have to mention what kind of error you want to handle. Now this is important. So let's go back to that restaurant near to the highway, which is an open restaurant. Now, a lot of things can go wrong there, right? One of the thing is my kid gets up from the table. That's critical thing for me. I have to handle it. But there are certain other situations as well. Let's say there is a dish which is getting overcooked. Now that's not my concern. I'm sitting on my table. That's a concern for the chef. Chef need to handle it, right? Or maybe there's something, other things that are happening there. Not my concern, right? So I should handle my exceptions. So in this situation, I should be very clear what kind of error I want to handle. So in this case, it is zero division error, which we got earlier. So we should handle that. But to understand what other errors we have, so let's go to the Python documentation and let's get into the exception hierarchy. Now, if you see here, the base exception is the top class exception. Okay, when I say top class, it's a pun intended. In the class hierarchy, it's a topmost class, but also the top best. Doesn't matter. I tried something, it's not working. But the main point is this exception. This is the main exception for us. So this can handle everything. Now, when I say everything, what it means, it can handle arithmetic error. If something goes wrong with your calculation, or overflow error, or there's a problem with the floating point, and there's also a problem with the zero division. So this zero division is a subclass of arithmetic error. Arithmetic error is a subclass of exception. Okay. Now, if you go down, there are more errors. Let's say we got buffer error, we got end of file error. Then what other things we can use? Yeah, file not found error. This is what I was talking about. The file does not exist. And recursion error could be one. Value error, which you're going to see later. So there are different kind of errors which comes under exception. So if you get any of this exception, and if you have exception which can handle it, it can handle it. So what I'm going to do is, in our code, let's write, instead of saying zero division, I will write exception. Okay, the main exception. And if you click on exception, you can see it's a class which is extending, or which is inheriting the base exception. And base exception is like a topmost class. It is not inheriting everything or anything. So you can get into exception. We also got stop iteration, which we might see later. And yeah, so we can see we got arithmetic error, which extends or inherit exception. Inside this, there should be zero divide error. Yeah, zero division error, which inherits arithmetic error. So now you know the flow, right? How it is doing. But now if you say exception, it can handle everything, So let's write exception and let's print here something. So let's print here by saying, okay, I think I made a mistake. An error occurred, division by zero is not allowed. Okay, this is what I'm going to write. I think I clicked something because of which I'm getting this thing. I don't want it. Let's stick to our own, the original terminal. Okay, so you got these statements and you're putting that in a try block. That's how thing works, right? So let me just save this and run. And you can see it says an error occurred, division by 0 is not allowed. That's proper. But if you observe, it is not crashing the application. You are saying end of the execution. This is important. It is saying end of the execution. So that's how basically you handle the try. I mean, you handle the statements by putting that in a try block. And then you try to handle the exception by using exception. And then you print something. I mean, it's not just printing. You can do some operations as well. Maybe you can do this operation again by changing the value of b. You can ask the user, hey, give a new value for the b, and then you can do that here and make it work. So you can do whatever you want in the except block. So that's how you use try and except. Now let's say you are taking the input from the user. So the way you can do that is by saying int. You have to also convert that. So let's say input. I will say enter a numerator, and here enter the denominator. That's perfect. And now let's see if this works. So let me just run this. Enter, asking for the numerator, 4, 2, everything works well. You can see it says result is 2.0 and then end of execution. Perfect. Now let's run this. I will say 4 divided by 0. Okay, it says error occurred. That's good. Division by 0, my mistake. And end of execution. App is not crashing. That's great. Let me run this again. 4, and I wanted to type 5, but then I entered T. When you say enter here, you can see we got an error and the app is crashing. How do I know? It is not printing end of execution. Now what went wrong? This line, which is b equal to this line, is the problem, and the error is value error. Remember, we talked about value error. I mean, I've shown you in that hierarchy. It says invalid literal for input because input function tried to convert into integer. It is trying to convert integer. T is not integer, so you cannot convert it. So these statements also become a critical statement. These are not normal statements. So I can just pick it up, put that in a try block. At least it should not crash it now. So let's run this. Okay. And run. Let's say 4 and 2. Everything works proper. Let's say 4 and 0. Everything works proper. And now let's say 4 and T. Okay, you can see for T, it's not crashing. It says end of execution, but there's some problem with the error message. It says error occurred, division by 0 is not allowed. It's not 0, it is T. What is going wrong? See, if something goes wrong with the try block, of course you will execute the except block. We only have one except block. It is going here. It is printing this message. Not a good message, right? Because the problem is different. What you can also do is you can print the message here. So you can just say exception E. So whatever exception object which is getting raised, you can put that in E and you can print E here. Okay, now you will get the error message. So 4 and T, you're getting this message because that's what you have written here, hard coded. But look at the E message. It says invalid literal for integer T. Perfect. So that's actually good. But then for 4 and 0, we are also getting the same message. Not a good style, but yeah, this message is different. This is same. So if you want to type a different message, don't you think there should be different except block for different kind of errors? Example, let's say if you're preparing for a board exam, and I remember my school time, when you're preparing for the board exam, before the exam, my school used to arrange this 10 days doubt solving sessions with your teachers. If you get errors, let's say for maths, we have a classroom where we have a maths teacher. You can go there, resolve your doubts. We have a teacher for science. You can go there and resolve your doubts. But there are certain doubts which no one can answer. Okay, maybe someone is bullying you, you lost your hall pass. In that case, you will go to your class teacher. So you can be very specific here. So exception, you can say this is 0 division error, and I can just write ZDE just to differentiate the objects. And the message is this. And then you can write one more except block, which is for the value error. And you can write a message like this. And then this works. And then you can have a universal exception where you can say unexpected error occurred. Now for the first two, for this particular except block, we got this is 0 division, this is value error. Now based on which error is arising first, it will execute that particular except block. Okay, so if I run this and if I say 4 and T, now this time it is not divided by 0 error, it is the value error. And that's why you can see it says an error occurred, invalid input, please enter numeric values only. And that's a proper message, right? And that's why, and since you are printing VE, again, it is printing the same message. You can skip VE now, right? That make much more sense, but let's keep it there for our understanding. If it is a 0 divided by error, it will print that message. So let's say 4 and 0, it will print division by 0 is not allowed, right? So that's for the 0 error. So it will not execute both. The moment it gets at least any one error, it will jump to the matching except block. Okay. Now I don't see any extra error here, but we just wrote this for our safety, right? If something goes wrong, which is not, I'm not handling it here, except will handle it. If you can generate any error which is not in this, let me know, and somewhere in the comments or in the notes somewhere for the others to see. Okay, so this is about try with multiple except block. Now we can talk about try with finally. See, what happens is when you work with the complex software, you work with databases, you work with network connections, you open files. Now, all these things are actually called resources, right? So database connections are resources, files are resources, and it is your responsibility as a developer. After using the resource, you have to close it, right? So let's say in this code, I'm not using any resources, but let's pretend we are using some resource. So I can say resource opened successfully. This can be database connection. This can be a file opening. This can be network connection. Resource opened successfully. And then I have to make sure I will close it. Now, which is the best place to close any exception or anything? The best place to close a connection is a final block. Now, final block is a block which will get executed even if you get the exception or even if you don't get the exception. Because see, the except block will execute only when you get the exception, right? Try block complete executions depend upon if you get the exception or not. If there is no exception, it will execute the entire block. If there's exception, it will stop the execution into try block and jump to accept. But final block executes irrespective if you get the exception or not. So it's always better to write final block in which you close the resources. So if you run this, let's run 3 and 4. You can see it says resource closed. And even if you get the exception 4 and 0, it will say resource closed. And even if you crash for some reason, so let's say I'm not handling value here, and let's see what happens. I'm just experimenting it here on the go. It says resource opened and it crashed. It crashed. Okay. So it's not printing end of execution, but it says resource closed. Doesn't matter if it is crashing or not. So before crashing, it will close the resource. And that's important. So that's why you should put things in the final block. Perfect. But there's one more important thing with the final block is, let's say if you don't put final block and try block, if you skip that, try block will say, try statement must have at least one except or a finally clause. Okay, so either you need except or you need finally. So you can also have a finally here. Maybe you can print something, clean up resources. So if you want to write try, either you need finally or you need except block, or you can have both. Just remember that. So yeah, that's it. That's it from the exceptions. I hope it makes sense. See you in the next part.